Hello, my name is William Wachesek. My science fair project for this year is comparing and contrasting fossil abundance and diversity at the Caesar Creek Emergency Spillway in Waynesville, Ohio. Spillway at Caesar Creek State Park, which is 40 minutes from Cincinnati, Ohio, is a world-famous collection site for ordovician fossils. The site has been visited by scientists from the Smithsonian and major universities as well as amateur geologists since 1978. There is nothing in the literature that shows that the fossil fauna has been mapped for diversity and abundance, especially in the face of intensive collection efforts. For my 6th grade science fair project, which happened in 2018, I sampled the western side of the spillway, more popular side, for collectors. I found the area closest to the parking lot had a lot lower abundance of fossils compared to the outer edges of the spillway. Yet the diversity of the fossil type was high throughout the western side of the spillway. Prime fossils include brachiopods, bryozoans, crinoids, trilobites, and cephalopods. For this year's science fair project, I sampled the less popular eastern side of the spillway. My hypothesis was that there was an expectation to see abundance and diversity of fossils in the lightly collected eastern side of the spillway, similar to the abundance and diversity for the lightly collected portion of the western side of the spillway. Materials and methods. The eastern side of the spillway is 210 meters long by 148 meters across. Sampled a total of 36 collection sites. 3 rocks were randomly collected at each collection site for a total of 108 rocks. Rocks were then observed from each sample site to determine the qualitative abundance of fossil types. Superabundant was 50 more fossil fragments. Abundant was 25 to 49 fossil fragments. Present was 5 to 24 fossil fragments. Minimally present was 1 to 4 fossil fragments. And not present, you guessed it, 0 fossil fragments. To see examples, look at attachments A through E. I then gave a numerical score for each category. Superabundant got 4 points, abundant got 3 points, present got 2 points, minimally present got 1 point, 0 points, and not present got 0 points. The western side of the spillway is the independent variable, while the eastern side of the spillway was the dependent variable. Results. Data from 2018 is available in Table 1, and data from 2022 is available in Table 2. Brachiopods were fairly abundant, with an overall score of 2.67 throughout the eastern side of the spillway, while bryozoans were present with an overall score of 1.64. Brachiopods in the western side of the spillway had a score of 2.72, while bryozoans had a score of 2.185. All other fossil groups, including crinoids, trilobites, etc., nearly non-existent from the eastern sample sites with de minimis scores. For the western side, trilobites had a score of 1.44, crinoids had a score of 0.69, cephalopods had a score of 0.129. Conclusion. My hypothesis from the study was completely disproven. What I learned is potentially more significant and improves the understanding of one of America's most celebrated sites for collection of ordovician fossils. Indeed, the lightly collected eastern side of the spillway had much less diversity, even lower abundance, especially with bryozoans, than the western side of the spillway. The western side of the spillway, which is highly visited, has lower abundance during the parking lot, while the high diversity of fossils is present throughout the western side of the spillway. The lightly collected side of the eastern spillway seemingly should have similar pattern of abundance and diversity, but it did not. The purpose of the emergency spillway is to quickly evacuate water from an impoundment from the reservoir during heavy periods of rain to avoid the failure of the dam. The spillway can have a downward gradient to use gravity to facilitate water flow. The Caesar Creek Emergency Spillway has an approximate downward gradient of 12 meters from the lake to the western side of the spillway. A 12-meter drop represents approximately 400,000 to 500,000 years of sedimentary rock layers, with the rocks on the high end, eastern side, representing the younger rocks with presumably more advanced and mature Ordovician communities versus the rocks the lower in the column. According to the succession theory seen in Figure 1, fossilized rocks higher in the column, such as the eastern side, typically have more diversity and abundance of fossils. More mature developed Ordovician communities typically have more biomass along the greater diversity of creatures. However, the succession theory did not hold with this dataset. The eastern side of the spillway, which is higher up the rock column compared to the western side of the spillway, which is actually had lower diversity and abundance of fossilized creatures. The snapshot of time represented by the eastern side of the spillway may have witnessed climate change or some other weather or geological phenomenon, pollution, mudslide, or etc., that greatly reduced the overall diversity and abundance of fossilized creatures. Indeed, succession theory is not foolproof, and looking at rocks as localized rock formations can represent changes in climate in local or regional manner. More studies could be conducted to pinpoint the exact time represented by the rocks in the eastern side of the spillway and the forces at work during the time period compared to the western side of the spillway. In summary, though Caesar Creek Spillway is a nationally popular location for professional and amateur geologists, it also represents a diversity of geological timeframes, including a snapshot in time on the eastern side of the spillway, where forces potentially subdue diversity and abundance and may hold important lessons as our modern world seeks to understand the potential impacts of climate change. Thank you.